Alright, so we're going to answer these trig questions, trig equations. So we're not supposed to use a calculator or a table, so we'll go over each one of them. Okay, so these are different from the other ones that we've done in the other video because these ones involve sec, these ones involve the secant squared theta, and then they also involve an equation which is that sine of theta is equal to 1 minus cosine of theta. So watch to the end to just see how we can handle these questions so easily. Okay, all right, so just start with the first one, and there we're given 2 tan of theta, secant of theta minus tangent of theta, then this is equal to a 0. How do we answer that equation? How do we go about it? Okay, so since we've got tan being common, we can just factorize it. So we're going to have tan of theta, open the brackets, you're going to remain with, for the first part, 2 secant of theta will still remain, minus a 1 for the other part, and this is equal to 0. So at this point we can have two equations. The first one is what is in the brackets, 2 secant of theta minus 1 is equal to 0. The other one is just tangent of theta itself being equal to a 0. So if we solve these two equations, then we've got our solutions to the question as a whole. Okay, so starting with let me start with a simple one, tangent of theta. Tangent of theta is equal to 0. So we know tangent of theta is the same as sine of theta over cosine of theta. And since at this point I've already given you the graphs to the sine and the cosine graph, and maybe for the sake of people who've not watched those videos, let me just give you a quick background so that we can actually do that faster. Okay, so sine graph starts from 0 and it moves like this. Okay, that's a sine graph. Okay, the maximum point of a sine graph is 1, the minimum is a negative 1. This occurs at 0, this occurs at pi over 2, that occurs at pi radians, that occurs at 3 pi over 2, and finally at 0 is at 2 pi there. Okay, so this is a fraction. Tan is only going to be 0 if the numerator is a 0. We can't divide by cosine being a 0. Okay, so a denominator can never be 0. So in short, tangent is only going to be a 0 when sine is 0 and cosine is not. So when do we expect sine to be a 0? So it's at 0 to start with. The other point is at this point, pi, and then also at 2 pi, right? That's why sine is 0. So expect tangent to be a 0 as well at those 3 points. Okay, so 0, pi, 2 pi. Okay, now if we look at the interest, what they're interested in is we're interested to have solutions from negative pi to pi. So 2 pi doesn't qualify to be part of the solutions. And so if you're to extend this graph to the negatives, you notice one thing, it's going to be like a reflection. So this is going to be negative pi over 2, and then that will be negative pi. So negative pi also qualifies to be part of the solutions. Okay, that's what we have for this part. Okay, if you want to see the cosine graph, just watch the video. The link is in the description below, the introduction to trigonometry. If you're on our site, just go to learn.transcendedinstitute.net and then go to mathematics, open trigonometry, and then you find this as the first video. Okay, very helpful, right? Of course, for those of you who know the special triangles as well, that can also help you. Okay, so let me just write them again. The answers there, we've got negative pi, 0, and pi radians. How do we handle this one? So in the similar manner, we can actually just secant of theta, we know it's 1 over cosine of theta. Okay, and that is equal to a 1 in this case. Okay, and then we've got 2 over cosine of theta being equal to a 1 when we multiply by that 2. So at that point, if you had to make cosine of theta the subject, what do you remain with? You're going to have 2 is equal to cosine of theta. Okay, what is the answer? What satisfies cosine of theta being equal to a 2? So I already showed you from the graph to say, from the sine graph I did draw, to say the maximum value was a 1, the minimum was a -1. So if you see a 2 like that, even for cosine it's the same. For tangent may be unique, but for cosine and sine this can never be true. So cosine of theta cannot be greater than 1. So no solutions. So therefore the only possible solutions that can satisfy that equation are those 3. Okay, so we can now move to B. Feel free to pause the video and just try it out. So for B we have 2 sine squared of theta plus 3 sine of theta. So we did a similar question under the other basic equation. So this is just a quadratic equation. Now answer it in a different way. Today what we're going to say is let our x be equal to sine of theta. So pause the video and solve that quadratic equation. Substitute. So where the sine of theta, we have x. So where it is squared, it is x squared. Equally there it will be 3x plus 1 is equal to 0. We can now solve the quadratic equation. Okay, the product here we go by factorization. The product is 2, the sum is 3. What two numbers can you multiply to give you 2? You add them and give you 3. I think it's 1 and 2. So 2x squared plus, so the middle part is going to be distributed or substituted by the factors. So 1x is just x, 2 is 2x. So you have 2x plus x. These are the ones that can give you 3x plus 1 is equal to 0. For the first part we can just factorize 2x, which is common. You remain with x plus a 1. The other part we just put the 1 so that we maintain the x plus 1 to match up with the other part. So the two equations we have is we've got 2x plus 1 when you get this part and that part, and then also x plus 1 equal to 0. Okay, great, right? Simple and straightforward. And so the two equations therefore that we have are, one is this 2x plus 1. So if you put back your sine of theta, where is x? So you're going to have 2 sine of theta plus 1, and then you're going to have sine of theta plus 1 equal to 0. So we have two equations there that we can solve independently. So 2 sine of theta plus 1 is equal to 0. The other one is sine of theta plus 1 is equal to 0. At this point you know how to solve these equations. I've already taught you this, the special angles from the special triangles, so feel free to pause the video and just try to answer these basic equations. Okay, so if you have, we have 2 sine of theta is equal to -1. Let's see if what you've answered is the same. So sine of theta becomes -1 over 2. This is a very basic equation. Okay, so theta is going to be sine inverse of that. Okay, not necessarily true, but yeah, that's what we're going to do there. But what I usually like doing here is we can actually take it, ignore it to be, let's assume it's a positive. So let's introduce a new variable. Let's call it alpha. Alpha is going to be sine inverse of the positive one, positive half. So understand that if we're dealing with it in terms of degrees, that could give us a 30 degrees, which of course is pi over 6 in this in the radians. So therefore this will give us a positive answer to be pi over 6, which is 30 degrees. Okay, for those of you who are thinking in degrees, this is pi over 6. Okay, now is this answer we're looking for? No, this is a positive result which is found in the first quadrant. Now our area of interest in this case is one to find the negative values, because that is negative half. So where is sine expected to be negative? All students take calculus. Clearly we can see that we're going to find the negative answers where tangent and cosine are positive, because in the first they are all positive, in the second sine is positive. So this is pi, this is 2 pi, that is pi over 2. To find the angle in the third quadrant, you add 2 pi. To find the angle in the fourth quadrant, you subtract from 2 pi. Okay, so let me remove that. So therefore the two theta angles are going to be one where we add 2 pi, and then the other one where we subtract from 2 pi. Okay, so common denominator there is of course a 6. 6 times the pi is 6 pi plus pi 7 pi over 6. The other one, now this is where I'm getting lost. I'm forgetting about that very fact there. So we're not interested in the angles that are beyond pi. Okay, so which will also disqualify this part here. Why? Because we want angles that are less than pi. So the fact that we only have a single positive result, we only have because less than pi, we only have positive values for sine, so we are not going to have an answer in that range. Okay, let's try to observe the other range, the negatives. So if we are there and we have got a positive 0 there, and this is pi radians, if you want to go the negative way, you go this way, so we're only going to get the negative results. Okay, so one will be in here, the other one will be in there, this way. Okay, and the concept is very simple. So we're still going to use the same angle which we used, okay, which is pi over 6, so 30 degrees in that quadrant. Now if we go down by the same magnitude, what are you going to have? You're going to get negative pi over what? Negative pi over 6. Okay, now if you're in the third quadrant, which of course in this case is like a second quadrant, so to easily find the answer here, you just can't find the refraction there by subtracting from pi. Okay, then just consider it to be a negative. So if you subtract from pi over 6, what are you going to get? So pi minus pi over 6, you end up with negative 5, or it should be positive 5 pi over 6. Now for the diffraction part, it will give you negative 5 pi over 6. Okay, I hope I haven't confused you there. So the answers that we found, negative pi over 6, and then also negative 5 pi over 6. Okay, these are the two answers that are going to satisfy that first equation, right? Now if you look at the other one, which is sine pi is equal to negative 1, of course if we cross the 1 to the other side, or if we add the additive inverse on both ends. When is sine negative, draw the graph without wasting time. So it's going to be negative at this point. Okay, now that is beyond pi, because this is pi and this is 3 pi over 2. We're not interested in that value, yet we're interested going the other side, so I can extend the graph going the negatives. So this is going to be negative pi, this is going to be negative pi over 2. So negative 5 pi over 2 is going to give us a negative 1 value as well. So we'll add it to the solutions that satisfy the whole equation. Okay, and that's it for this question. 3 solutions. I think at this point now you've gotten the idea, you've gotten how we are solving these questions. And so if you look at C, I believe it's not going to be a struggle for you. We've got secant square of theta, and then minus secant of theta minus 2 is equal to 0. Okay, so feel very free to try out that question. Okay, feel free to pause the video and just try it out. Okay, so if you're enjoying this video and you want several questions on trigonometry, we've answered the full tutorial sheet based of this topic. Okay, beginning from the basics there all the way up to the identities, the sum angle formulas, different unique equations. Okay, and then interesting concepts that involve within the sketching, the graphing. All these questions have been answered in this very video. Of course, with an addition of now where we can apply trig with some complex numbers there and several other videos in mathematics that involve calculus, binomial topics in semester 1 or semester 2 of your learning. Okay, so the link is in the description below to our site where you're able to access the solutions to all these. Okay, let's just get back into it. So we are on C. Of course the numbering wasn't okay, it's supposed to be okay. So C secant square of theta minus secant of theta minus 2. How do we handle it? So we'll treat it as well as a quadratic equation. So we can have x squared minus x minus 2 equal to 0. We can factor out the product is minus 2. The sum is the middle part, which is the coefficient of x, which is a negative 1. What are the two numbers we can multiply to give us negative 2? We add them to give us negative 1. So negative 2 and 1. Whenever you've got a coefficient of 1 there, don't even waste a lot of your time. Just get the coefficients or just get the factors. So you're going to have x minus 2 and then x plus 1. Okay, we factorized. So you know our x, we said let our x be equal to a secant of theta. So you can bring back a secant of theta. So we have secant of theta minus 2, secant of theta plus a 1 equal to a 0. So we can now solve these two equations independently. Okay, so the first one is what? Secant of theta, and then if this goes the other side, you're going to have equal to 2. The other one is secant of theta negative 1. I think you can actually see that we actually experienced a similar situation previously when we looked at the other question, right? Okay, so secant of theta is the same as 1 over cosine of theta, and then this is equal to a 2. If you cross and multiply, you're going to have 2 cosine of theta, which is equal to a 1, and then cosine of theta will now be equal to 1 over 2 if you divide by 2. Okay, so we're ending up with cosine of theta is equal to 1 over 2. Now ask yourself a question. So go and look at the 30-60 special triangle. I've talked about it several times. Look it up on our site. Okay, link to it is in the description below. So when is cosine half? We know for sine it's 30 or pi over 6. So this is now for 60, which is of course pi over 3. Okay, so pi over 3 is 60 degrees. Why am I saying pi over 6? Pi over 3. I'm saying something else, I'm still writing 6. Pi over 3. Okay, that's the angle that is able to satisfy this. Okay, now we have to look at the entire range, which is all the way from negative pi to the negative. So let's look at our quadrants. All students take calculus. This is 0, this is pi, of course, stroke negative pi. Where is cosine positive? It's positive in the first and in the fourth quadrant. Okay, so already if we had assessed from 0 to pi, we can't find cosine to be positive, so already discard the positive results other than the one in the first quadrant. This one is going to be negative. So instead of wasting time to try to find the angle in that quadrant, we'll straight away proceed and look at the third quadrant, which we can access this way by going towards the negative pi. Okay, so just the diffraction of it is the answer. So the diffraction of that, which is of course going to be negative pi over 3. Okay, we can still proceed. I believe this quadrant as well is still, now this quadrant gives us a negative result, so we'll just discard it because cosine is only positive in the fourth and the first quadrant. So these are the two answers. Start with a negative to make it look more neat. Negative pi over 3 and then pi over 3. Okay. Now look at the other one. Secant of theta is equal to negative 1. So of course 1 over cosine of theta is equal to negative 1. So cosine of theta itself is going to be what? Equal to a negative 1. Is it? yeah, that should be the case. If you cross multiply, you end up with negative cosine equal to 1, and then you still end up with that result there. So when is cosine negative? Just look at the graph of cosine. I told you to look it up. If you haven't, you're lucky. I'm going to draw it for you. Okay, so what is 1, negative 1? This is pi over 2. This is 3 pi over 2. So that is 3 pi over 2. Is it? No. This is pi. This is pi over 2. And this is 3 pi over 2. So it's actually pi. Okay? So solution there is pi for the negatives or for the positives. So if we extend it to the negatives, of course this is going to be pi over 2 where it's cutting 0, and then this is going to be negative pi. Okay, so negative pi. So you've actually noticed that in a case where we are looking at these solutions, if you are dealing with the positives, the secret is if you're dealing with the positives and then also negatives, if your answer is in the first quadrant like this, the diffraction in the other quadrant is the same, just change the sign. So equally, if you find a positive answer to be pi, it will be negative pi in the other direction as well. So therefore we've got 4 solutions, so negative pi and also positive pi. Okay. Now we'll move to D. D is very interesting. There we've got sine of theta, cosine of theta, minus cosine of theta is equal to 1 minus sine of theta. Okay, so how do we handle this question? Okay, so link to the full video is in the description below. Check it out to watch the full video and several other questions on this topic that I showed you before.